Hello, good evening students. Now today we are going to understand the elimination reaction. Elimination reaction of elimination reaction of haloalkanes. Haloalkanes. Dear student, so there are elimination reactions. It follow that is a certain types are there for the elimination reaction. When you are talking about the first type, when this one is the E1 elimination, this is the E1 elimination. Elimination. When you are talking about that is again is there, that is E2 elimination. E2 elimination. And last one is there, that is Set-Jeff rule. Set-Jeff rule. So there are the three ways we can do the elimination reaction of the haloalkanes and haloarenes. So what is the process for the E1 elimination reaction, student? It is just like E1 elimination means just like that it is S1 type of, So this comes under that is it gives it follows what, student? It follows that is carbocation formation. It follows, the first point is it follows that is carbocation formation. This is the first things that we have to keep in mind. And second point, that is in the second point in this case, that is it takes place, where it will takes place, student, takes place in that is 3-degree alkyl halide. Now student, how can you be able to understand? Suppose we are having that is 3-degree alkyl halide is there. Okay, here is Cl and this one, this direction CH3 and this direction CH3, this is also CH3. So what is happening in this case, student? This is reacting with the alcoholic KOH. It is reacting with the alcoholic KOH. So alcoholic KOH is a strong base, student. So what it will do, student, it will directly eliminate, and what it will form, it will not give the substituted product, student. It will give here is CH3 and here is double bond, that is this will go CH2. This is alkene. Now student, we have to understand how the reaction taking place. So let us try to understand the mechanism of E1. Mechanism of E1 reaction. So how can you write the mechanism of E1 reaction, student? So it involved in the two steps. Step number 1, if you talk about step number 1, so that is formation of carbocation. That is in the first step, that is formation of carbocation takes place. So that is here is what is, student, that is Cl is there and this CH3 as usual, that is 3-degree alkyl halide. So what is there is the difference in electronegativity. So will be there taking place the homolytic fission, student. So in the case of homolytic fission, that will be the reversible process. So what it will give, student, it will give that is CH3, okay, and here will be also CH3 and downside CH3, and this is the positive charge. Step number 2, okay, step number 2, that is you can write that is elimination of what, student? Elimination of H plus. How elimination of H plus will be taking place, student? Let us see. So in this reaction, the same is I am writing this carbocation. So positive charge is there and this is CH3, this side also CH3 and this side, that is CH2 and H is there. So what will happen there, OH base, what it will do is, student, this OH base will attack on this hydrogen and this bond will be shifted here. So what will be the final product will be there, student? Here is CH3, no problem. This side also CH3 as usual place, and here will be the double bond CH2 plus water will be formed. So in this total process, student, if you check out the total process, what you will be finding, student, in this total process, you will find that there is a loss of hydrogen as well as halogen. Okay, so here is the loss of, you will find that is, here is the loss of halogen will be there, and this will be the loss of hydrogen from here. So this elimination reaction is also known as dehydro. This is known as dehydrohalogenation reaction. Okay, that you have to keep in mind. That is, two things are getting eliminated. That is why this reaction is also known as dehydrohalogenation reaction. Now student, what we are going to do, we are going to understand the E2 elimination reaction. So E2 elimination reaction follows just like the SN2 reaction student. So in E2 elimination reaction, it generally takes place in the 1 degree alkyl halide student, and that reaction is also known as beta elimination reaction. This reaction is also known as a student, that is beta elimination reaction. So let us try to understand student, how can you be able to understand in this reaction when you are talking about, that is takes place in where student takes place in 1 degree alkyl halide, 1 degree alkyl halide. That is the very first point student. And when you are talking about the second point, that is transition state form, transition state form. Okay, this is the second point. Okay, so student, how the reaction will be proceed here in this case, you check it out student. So here is, suppose we are having that is CH3 CH2, and here is I am putting Cl, and this hydrogen I am breaking out, and here I am putting that is hydrogen, and here is 2. So you can match it out, the valency of this carbon 1 2 3 4, and this one also. So what is happening student, in this case the attack will be from the back side. So backside attack is from OH minus ion will be attacking from the back side. So if OH minus ion is attacking on this hydrogen, so this bond is breaking out, and this bond will be chlorine will be coming out. So what the transition state will form student, let us check it out, this transition state formation. So here is what is happening student, CH2 is there, and this side this side what is happening, this one is the OH, OH is getting forming the bond with which one student, with the with the hydrogen. Either you can write in this one in the bottom also, there is no problem. Here hydrogen is there, so here is OH is forming the bond student, OH. So in this case, here will be, this bond will be shifting out. So if this bond is shifting here, so here will be double bond, and then here is CH2 is there, and this bond will be the broken out. So this will be going like. So next step what will happen student, it will be minus Cl and minus H2O, minus Cl minus H2O, and finally it will be shifting here. So what it will form student, CH2 double bond CH2. This is what is known as student, this is what is known as ethene, right? So this reaction is what is SN1 reaction. This step is known as TS, transition state. Okay, so this is the mechanism of the SN2 reaction, E2 reaction, that is just like the SN2 mechanism. Now next one is there student, that is known as what, Sedgwick rule. So let us try to understand the Sedgwick rule, and that is the quite important, the out of all the elimination reaction, Sedgwick rule is the most important rule for the competitive exam also. Okay, so Sedgwick rule, what it is saying student, what is the Sedgwick rule is saying? Sedgwick rule is saying, if there is more than 2 beta hydrogen present in where student, alkyl halide, in alkyl halide. So that is alkyl halide. Then the preferred product, what would be the preferred product? Then the preferred product will be what student, product will be, that is will be having, preferred product will be having more number of alkyl group, more number of what student, more number of alkyl group. Okay, more number of alkyl group. This is our will be answer in alkyl group. So student, how you will be able to understand the mechanism of this reaction? Let us try to understand this. Suppose we are having CH3, here is CH, okay, and here is, suppose that is the CH, and I am putting hydrogen here, and then again I am putting, here is CH, and this side there is Br is there student. So CH2, and there is what this is the Br, and suppose this is the also CH2, and here I am putting hydrogen. So case number 1 I am doing student, case number 1. So case number, if you are treating this with OH, So probability is there if it is attacking at this hydrogen. So this bond will be shifting out and this will be coming out. So what the product will form is student CH3. Okay, there is nothing happen with this carbon, so it will be there CH2, and that is here is the what is writing student. This is the one bond is going, bromine is going and this bond is forming. So that is CH double bond CH2. Okay, so it is having only one alkyl group student. This is only one. So this is not symmetrical alkene. So this is known as what? But 1-ene. This is also but 1-ene, and this is also known as Hofmann product. If the Hofmann product, and this is only 19% student, 19%. Now you see the case number 2. According case number 2 for the Sedgwick rule. Case 2 for the Sedgwick rule. So dear student, how you will be able to do the same compound I am writing CH3, and that will be CH. Okay, suppose this hydrogen is here, and that is here is CH, and that is Br is as it is, and here is CH3. So if you are taking place by OH ion is attacking with this, so this bond will be shifting here, and this all the bromine will be out. So what the compound is getting formed student, you see CH3, now it is CH. Okay, and this is bond is shifting here, so this will be double bond, and here is CH, and that is CH3. So how many alkyl group are there? Here is only one alkyl group student, here is two alkyl group. So product will have more number of alkyl group, so two alkyl group. So here is what is there student, this is the 2 alkyl group. So 2 alkyl group present means this is the Sedgwick product. Now if this is the Sedgwick product student, so it form how much student? 81%. So this is the major product. So either you say that is Sedgwick product, or the one more name is there student, we use one more name. The other name is known as also Jetsov product. Okay, ZETSAV, Jetsov product. So it is having the two names student, Jetsov product or the Sedgwick product, both are the same. So this is all about the elimination reaction of the haloalkane and haloarenes. Okay, thank you so much for watching friends. Hello students, now let us see the preparation of haloarenes. So how can you be able to prepare student haloarenes? So haloarenes are what student? That is in the arenes group. Arenes means that is benzene or aromatic compound. If in that group student any halogen atom is attached, any halogen, that is what is known as student haloarenes. Now student, now we have to prepare this haloarenes or chlorobenzene. So how can you prepare? There are so many n number of methods are there student. Let us go for the one by one method. So that is first method is from benzene diazonium chloride. First method is from benzene diazonium chloride. So student, what is benzene diazonium chloride? First of all, we have to understand what is the benzene diazonium chloride. So if you try to understand the benzene diazonium chloride student, so there is the structure is there student. This is the benzene ring. Okay, and with this benzene ring, this benzene is attached with the diazonium group, diazonium chloride, N2Cl. So Cl is minus, and this will be the positively charged. So this compound is whatever the compound is mentioned here student, this compound is known as benzene diazonium chloride. Now student, what we are going to do with this compound, there are n number of reactions are possible, and this is the benzene diazonium chloride is very important reagent for the chemical compound, preparation of the chemical compound. So 4 reaction I am making from the benzene diazonium chloride. First reaction, what is there? We are writing student Sandmeyer reaction. So Sandmeyer reaction, what we are doing is student. Okay, firstly let us write the Sandmeyer reaction. Next one is there is student Bulge-Simon reaction. Bulge-Simon reaction. So that is second reaction. Next one is Garter-Mann reaction, Garter-Mann reaction, Garter-Mann reaction. And last one is their reaction with the, if you talk about the last one, reaction with the Ki, Ki, and when you are heating, that is in the heat. So student, Sand-Meyer reaction, what is meaning of Sand-Meyer reaction? If you are taking, that is student, if you are taking, that is any halogen you are taking, student, in the presence of cuprous chloride, CuCl is there, and you are treating with the CuCl, and you are taking, that is acid you take HCl. So what it will give, student, it will form the product having the chlorine group. So this will form, that is chlorobenzene. Similarly, if you are Bulls-Simon student, Bulls-Simon reaction, so you are taking, that is BF3. If you are taking BF3 and or you can take, that is HF student, then what will happen, student? What will happen? It will form, that is it compound will form HBF4. This HBF4 student, what it will do? It will act as a fluorinating agent for the benzene. So here it will form, that is fluorobenzene. This one compound is, that is what, student? Chlorobenzene. And next one is, that is this one is the fluorobenzene. This is the fluorobenzene. Next, when you are treating with the student Garter-Mann reaction, so you take the copper powder, student, copper powder, and this copper powder you treat with any of the acid, student, HCl. So what it will do? It will directly it will give, that is chlorine will be attached with the benzene ring. So this is also the reaction for the preparation of what? Haloarenes. So this is also chlorobenzene. And next one, for the direct preparation of iodobenzene, what we are treating this one, benzene diazonium chloride with the Ki, and then we are heating. So what the compound you will be able to get, student, in this process? You will be able to get the iodobenzene, student. This is the compound. What compound you are going to get, student? This is the iodobenzene. This is our four different haloarenes you will be able to get from the benzene diazonium chloride. If you want to understand in the little detail, student, that these reactions are quite easy only, that you have to memorize the mechanism of these reactions. These reactions are not available, student. Okay, but Sand-Meyer reaction or the Bulls-Simon reaction or Garter-Mann reaction, these reactions are very much important for the conversion, student. So that is, first of all, what we did, student, we took, that is benzene diazonium chloride. Okay, benzene diazonium chloride means, that is diazo group is there, N2NCl. This if you are treating with, student, cuprous chloride, CuCl or Cu2Cl2 or CuCl, and plus you are taking, that is HCl or HBr. So what you will be able to get, student, you will be able to get, that is chlorobenzene. This is chlorobenzene. This reaction is known as what, student? Again I am Sand-Meyer reaction. Okay, if you are a student, the same compound if you are taking, that is benzene diazonium chloride, here is N2Cl, and if you are heating, treating this compound, student, copper powder plus any acid you can take, student. So it will directly it will give, that is chlorobenzene. So either you take cuprous chloride or copper powder, the same way you are going to get the product. If next one is the Bulls-Simon reaction, student, this is Garter-Mann reaction, student, Garter-Mann reaction. Now, student, if you suppose you are going for the Bulls-Simon reaction, you are having the N2Cl, and here if you are taking what, student, that is BF3, BF3 plus you are taking HF. So this compound is combining and forming HBF4. This is the fluorinating agent, student, and this reaction is known as Bulls-Simon reaction. Bulls-Simon reaction. So what it will compound, it will give, student, it will directly add, replaced by the fluorine. N2Cl group will be replaced by the fluorine. So this is the fluorobenzene. Last one, if you are talking about that one, diazonium chloride is there, student, N2Cl. Here is we are having N2Cl, and if you are treating with the Ki, student, Ki. So what will be there, student? This Ki has to be heat out, student. If you are heating this, so it will replace this diazonium chloride group will be getting replaced by what, student? That will be replaced by I. So this will be what, student? This will be the iodobenzene. So like this, from the diazonium chloride we will be able to prepare the haloarenes. Now let us move for the another method, students. So next one is there, student, that is the second method is by direct halogenation, by direct direct halogenation of arenes, by direct halogenation of arenes. So how can you do the direct halogenation of arenes, student? So suppose we are having the benzene ring, student, we are having benzene. So what you are going to do is with this direct halogenation, student, so take the benzene ring and directly treat with the chlorine, heat with the chlorine in the presence of any metal catalyst. Suppose we are taking the Fe catalyst. So what it will give, student, it will directly add on to the here will be, that is chlorine, and that is HCl will form, student. This is what is known as, student, chlorobenzene. So if you are going to, if you want to have the direct haloarenes, so directly you take the Fe metal, okay, scrap of the Fe metal and treat with the chlorine, and you will be able to get the chlorobenzene. And now next one is the Raschig process, student. Next one, third method is Raschig process, RASCHIG, Raschig's process. Our student, in the Raschig process, this is also important for JEE, it is not there in CBSE, student. So benzene you are treating with the HCl and oxygen, student. So if you are having the, this is, suppose we are having the benzene ring, student, this benzene ring is being treated with the HCl benzene with the half mole of oxygen, student, in the presence of reagent you are taking, that is CuO, okay, and that is what is 25 degrees Celsius at room temperature. So it is going to give, that is haloarenes, student. So that is, here is Cl is there, so simply it will add on here, that is chlorine, student, and along with that it will release the water molecule, right? So it will be able, we will be able to get the water molecule, one hydrogen from here and one here and one oxygen here, so it will give. So this is the Raschig process. Now let us move on the another fourth method, students. The last method is, student, Huns-Diecker reaction. Huns-Diecker reaction. So if you are student, Huns-Diecker reaction, this is also not in CBSE board, student, but it is very much important for the NEET and JEE students. Okay. So if you are talking about the Huns-Diecker reaction, student, so we are taking, that is silver salt of any acid, student. So suppose we are taking, that is COO, OAG. So this is minus, this is plus. So silver salt of benzoic acid we have taken, student. Silver salt of benzoic acid we can write here, that is silver salt of benzoic acid. And what the medium you are taking, student? CCl4, carbon tetrachloride, and you are treating this with the bromine, student. This we are treating with the Br2, and what medium you are taking, that is non-polar medium we are taking, student, carbon tetrachloride. So what it is going to form, student? It is firstly, total group is getting out, and here is, student, in this one, here is bromine will be getting added, and that is one compound will be AgBr, student, and another compound, what is being AgBr, what is left, student? Carbon dioxide. So another compound is carbon dioxide. This is what is known as bromobenzene. So total this reaction is known as Huns-Diecker reaction. So in Huns-Diecker reaction, what we are taking, student? Silver salt of benzoic acid or any acid. If you are treating this with the bromine in the carbon tetrachloride solution, you are going to get haloarenes, that is chlorobenzene. So this is all about the preparation of haloarenes, student. Now we are going to understand the chemical properties of haloarenes. Thank you so much for watching, friends.